Now, part 2 in this lesson, it's how to find the general formula for a unique solution of a system of equations. But the system is all unknown. So how are we gonna find the general solution? So if I have the following system, ax plus by is equal to e, and cx plus dy is equal to f. Sure, the coefficients are not equal to 0. First, I need to find x. To need to find x, I need to think about eliminating y. So how are we gonna eliminate y? So we need to look at the coefficient of y here, it's b and d. So I need to multiply the first equation by d. So I will have bd here, and here by minus b, so minus bd, and then we will add the two equations. So by multiplying the first equation by d, I will get dax plus dby is equal to de. And by multiplying the second equation by minus b, I will have minus bcx minus bdy is equal to minus bf. And now we add the two equations. By adding the two equations, those two they will cancel each other. So dax plus minus bcx. So the best way is to factorize by x. We're going to have x factor of dA minus bc. It's equal to dE minus bf. And then what you will have, x is equal dE minus bf over AD minus bc, or dA minus bc. It's the same. I'm done with x. Now I need to find y. To find y, I need to eliminate x. So I have here a, the coefficient of x, and here c. So the best way is to multiply x by c, and the first equation, sorry, by c, and the second equation by minus a. And now I have the coefficient are opposite, and then I will add the two equations. I will have those two, they will cancel each other. I will have here CBY minus ADY, so I will factorize by y factor of CB minus AD is equal CE minus AF. But to have, guys, the same denominator AD minus BC, what I did here is I multiply up and down by minus 1 to have the same denominator for x and y, so we'll be able to memorize it easier. So what will be y is equal to AF minus CE over AD minus CB. Now, to understand all what I did here, the best way is to solve an example like this example. So let's summarize a little bit the solution. So if I have a system of unknown ax minus by is equal to e, and cx minus y is equal to f, the solution is the denominator, the both denominator are, you look like this, ad minus bc. Now for x, I will start here. It's ed minus bf, and for y, it is af minus ec. So this is the solution, and now I will put the solution in front of me here, and I will solve this example from the book. It's page 205. It's 3Q exercise 1. So I need to find the solution of this system. The best way is first to identify what is A, what is B, what is C, D, E, and F. A is 3, B is 1 plus I, like this, A, B, C, D, and then E, F. C is 4 minus I, D is minus 1 plus I, here it's I, and E is 4 plus 5I, and F is 7. And then the best way is to start by the denominator. It's AD minus BC. So AD, it's a 3 times minus 1 plus I, minus B times C minus 1 plus I times 4 minus I. And then I develop 3 times minus 1 minus 3 plus 3I. Need to be careful for the sign. It's minus 1 times 4 minus 4. Minus 1 times minus I, it's I. Minus I times 4 minus 4I. Minus I times minus I, it's plus I squared. I squared is minus 1. Now, if I add the imaginary part, you notice that this is a complex numbers here. 3I plus I, 4I minus 4I is 0. So I just have the real part here, minus 3 minus 4 minus 1, so it gives me minus 8. Now I need to do the same for ED minus BF and AF minus EC. So ED minus BF, it gives me 4 plus 5I times minus 1 plus I minus FB minus 7 times 1 plus I. And then I develop minus 4 plus 4i minus 5i plus 5i squared minus 7 minus 7i. Don't forget that I squared is minus 1. The part of this solution is minus 4 minus 5 minus 9 minus 7 minus 16. And then 4i minus 5i minus 7i gives me 8i minus 8i. Now we go to AF minus CE. It's 7 times 3, it's 21, minus C times E, and then I develop here minus 4 times 4 minus 16, minus 20i, minus times minus, plus I times 4, 4i, plus I times 5i, 5i squared. I squared is minus 1, so this is minus 5. And then I add the real part together and the imaginary part together, and we'll get minus 16i. And now once I got all those expressions, I need to find x. X is equal minus 16 minus 8 over minus 8. Then I can separate to simplify, and I will get for x 2 plus I, and I will get for y 2i. This is this part. Now we're gonna move after this part to how do we solve a system of 3 linear equations with 3 unknown. Since I still have time, let me just check the time. Yeah, since I still have time, I will start a little bit to talk about it. So to solve a system of 3 linear equations, I have many methods. I have method 1, and this method is algebraically. It means I can do it by substitution or elimination like we were doing it before with the two system of equations. Method 2 is also algebraically, but it's another method. It's not one of that we know it. It's called the row reduction or Gaussian method, and we're gonna use matrices to do that. Okay, so I will start first method 1, substitution, and then I'll do just the substitution in this video, and then in the second video I will do the elimination and the Gaussian method. So when I'm talking about substitution, it means you choose one of the 3 equations. You need to be careful. I pick one. I calculate one of the variable in terms of the other 2, and then I substitute this variable in the other 2 equations. I don't touch anymore the first one. So I pick any one. The best is to pick this equation where the coefficient is 1. So here in this case, either you can choose the first one to find y in terms of x and z. You could choose the second one to find x in terms of y and z, or you can choose the last one to find y in terms of x and z. But you need to be careful. When you pick the equation that you pick to calculate one of the variable in terms of the other 2, you can't choose it anymore. You just replace it, substitute it in the other 2 equations to have a new system of equation, but it is just with 2 variables. And then once you get the other 2 variables, you will replace it in the first equation. So I took here the first equation, y is equal minus 2x plus z plus 5, and then I will replace y in the second and in the third by minus 2x plus 7 plus 5, and then I will develop. When I will develop here x plus 4x, I have minus 2z minus 10 minus 3z is equal to 0, and the second one I will have 5x plus 2x minus z minus 5 plus 2z is equal to 1, I will get the following system. So I have now 5x minus 5z is equal to 10, 7x plus z is equal to 6. If you look at the system, it's a system of 2 equations with 2 unknowns. So either you can continue doing this by substitution or by elimination. But I will continue here by substitution on purpose because I will later keep the elimination for the second method. Now I can notice here that I can divide by 5. You could calculate easily from the second one z in terms of x and then replace the first one to find z and then x and then y. But I notice that the first one, if I divide by 5, I will get x minus z is equal to 2. Then I can find x in terms of z. I'm still doing the substitution. X is equal to 2 plus z. Now I can replace x by 2 plus z in the second equation here. So I will have 7 times 2 plus z is equal to 6. I will continue solving. I got z minus 1. Once I have the first variable, it's easy now. I'll go backward. I will replace z here by minus 1. I will get x. So x will be 2 minus 1, 1. And then how are we going to find y? I will replace it by the first equation that I substitute with it the other two equations. I will replace x by what I did, z by the value that I got, and then I will get the final answer for y is 2. And then this is the solution. We will write it in order x, y, and z. Now, in the second video, I will do the same system, but I will solve it by elimination, and then we will do the Gauss method, or we say also the row reduction method.